Hello students. Now we started the new chapter halogen derivative. When I say halogen, we know that fluorine, chlorine, bromine and iodine, astatine, out of which astatine is a radioactive, so we are not used. So these four halogens we can use in organic chemistry. So when I say halogen derivative means the the hydrogen of the organic compound if replaced by the hydrogen of the organic compound is replaced by halogen then whatever the compound you are obtained is the halogen derivative of organic compounds. So we know that when you consider the organic compounds or when you consider the organic chemistry which contain the organic compound. So organic chemistry on the basis of the carbon skeleton, organic compound can be classified as a open chain or close or ring chain compound. So when I can say open chain compound, they are aliphatic compounds. So they contain alkanes. Because they contain open chain. If you consider example as a 2-carbon alkane, they have the open chain of the carbon. So therefore they called as a open chain compounds. Remember, open chain compound may contain straight chain and branched chain. So when I say open chain compound, alkane is a type of saturated. When I say aliphatic compound, in which a saturated compound, similarly I consider a unsaturated compound. They are also a open chain compound that contain alkenes and alkynes. We may take the example of alkenes, that is a 2-member alkenes, that is a CH2 double bond CH2, that is the ethene. And when I consider alkyne, that is a 2-member alkyne, that is the ethyne. So ethane, ethene and ethine all are the open chain compound. Only difference is that alkenes are the saturated aliphatic open chain compound and alkene and alkyne are unsaturated aliphatic open chain compounds. So when I consider the halogen derivative, I have to consider the halogen derivative by replacing the hydrogen of the alkene and alkynes. So suppose I replace one hydrogen here, I get CH3CH2X. So this is called it as a haloalkanes or alkyl halide. Where one hydrogen I replace by. So if I replace one hydrogen, either this hydrogen or this hydrogen, I get the compound like this way, where X is the halogen. It may be fluorine, chlorine, bromine or iodine. So here I get haloalkenes by replacement of one hydrogen. If I replace one hydrogen from alkyne, I get this compound. This compound is also called as haloalkynes. So remember, haloalkane and haloalkynes are the halogen derivative of open chain compound. They are aliphatic, either saturated or unsaturated. When I say closed chain compound or the ring compound, they may be homocyclic. A cycle is made up of only one carbon, or heterocyclic. They may be homocyclic or heterocyclic. The homocyclic are also called as carbocyclic. Okay, so when I say homocyclic or carbocyclic, they also contain the two type of the compound. One is the alicyclic and another is the aromatic. So we know the example of early cyclic: cyclobutane, cyclopropane, cyclopentane, cyclohexane. So they are the cyclic but having the property same as aliphatic. So when I say aromatic, aromatic compound has benzene and benzene derivatives compound. Suppose I consider benzene derivative, it contains at least one benzene ring. So suppose there is benzene or chlorobenzene or phenol. Chlorobenzene or phenol. This is a chlorobenzene or this is a phenol. So they are the class of aliphatic and aromatic compounds. Okay. So here the hydrogen can also be replaced. If the hydrogen of the suppose hydrogen, here example is the cyclohexane. If the hydrogen is replaced by the halogen, they use a corresponding alicyclic. They use corresponding alicyclic halo compounds. Similarly, the aromatic can use a corresponding aromatic compound and they are called as a aryl halide. They are called as aryl halides. So like this way, in this chapter we are discussing haloalkanes, haloalkenes, haloalkynes or aryl halide as a class of compound which are obtained by replacing one or more hydrogen by one or more halogens. If you replace more than one hydrogen, that may be considered as a halogen derivative. So halogen derivatives, the compounds which are obtained by replacing one or more hydrogen by one or more corresponding number of the halogen, whatever the compounds are obtained are called as halogen derivatives. Okay. So now consider, so when I consider haloalkanes or haloalkenes or haloalkynes or aryl halide, here the halogen is attached to the whatever the carbon skeleton. So this classification of the halogen derivative on the basis of the carbon skeleton. With carbon skeleton, if I consider, because halogen is the same. Suppose I consider all halogens are the chloride. So I get a alkyl chloride, or here I get a chloroalkenes or chloroalkynes or chloroaryl compounds. So whatever halogen I consider, so all these are the halogen derivative in which the halogen is attached to the carbon, which carbon has a different carbon skeleton. So on the basis of the different carbon skeleton, the halogen derivatives are considered. Okay. So look here. So I can again say here. So when I consider the homocyclic compounds and heterocyclic compound, in which I consider example of the homocyclic compound as a alicyclic compounds and aromatic compounds. So in alicyclic compounds, I consider suppose example as a this is a cyclohexyl chloride, and in aromatic compound I consider a this is a hexyl it is a chlorobenzene. When I consider this aryl halide common, I say it is aryl halide, this is a chlorobenzene. So like this way, on the basis of the carbon skeleton, we consider the classification of the halogen derivative. Okay. Now on the basis of the number of the halogens present, we can also consider the classification of the organic compounds on the basis of the number of halogens. So when I consider on the basis of the number of the halogens, the compounds classification I consider as a monohalogen, dihalogen or trihalogen or tetrahalogen. Okay. So on the basis of number of halogens, on the basis of number of halogens present, they are classified as a monohalogen, dihalogen, trihalogen, tetrahalogen, or I say a polyhalogen. I say it is a polyhalogen in common, right? So when I say monohalogen derivative, so how I obtained a monohalogen derivative? Monohalogen derivatives I obtained by replacing one hydrogen by one halogen. So it is obtained by replacing one hydrogen by one halogen. So in which we consider example as a any alkyl halide. Suppose I say it is the propyl chloride. So here one hydrogen of the propane is replaced by chlorine, so I get a propyl chloride. In a dihalogen we consider, suppose I have the ethane. In the ethane, the hydrogen of the ethane, if I replace, I write hydrogen like this way. So I have to replace these two hydrogen. So replacement of these two hydrogen will be possible by the two way. Suppose I replace the two hydrogen from the 1 and 2 carbon, they are called vicinal. If they replace on the same carbon, they are called geminal. So dihalogens means the compound which contain the two halogens. They are obtained by replacing two hydrogen by the two halogens. So they are geminal dihalides or they are vicinal dihalides. When I say it is a geminal dihalide, suppose I consider example as a CH3, I replace both the hydrogen from carbon number 2, so I get CHCl2. If I replace from the adjacent carbon, I have the example like this way. Okay. So this is a geminal dihalide of the ethane and this is a geminal dihalide, vicinal dihalide of the ethane. Difference is that whether the hydrogen is replaced from the same carbon or of the hydrogen will be replaced from the same carbon to the halogen or from the different carbon. So I get geminal and vicinal dihalide. So when I consider the trihalogen derivative, the trihalogen derivatives is obtained by replacing the 3 hydrogen by the 3 halogen. Suppose I have the methane. If the 3 hydrogen I replace, I get a CHCl3 or CHBr3 or CHI3 or CHF3. So all they are called as haloforms. This name of this compound is a chloroform or bromoform or iodoform or fluoroform. So like this way, in general, they are called haloforms. So out of which the chloroform and iodoform, they are practically exist. The bromoform and fluoroform are the theoretically exist. The next is the tetrahalogen derivative. So tetrahalogen derivatives, it is obtained by replacing all the hydrogen. Suppose I consider methane, then if the all hydrogen are replaced by the all halogen, for example, if I replace it by the CCl, chlorine, then I get CCl4, that is called as a carbon tetrachloride. So that is one of the good solvent, carbon tetrachloride. So this is a tetrahalogen derivatives. Okay. So like this way, consider tetrahalogen derivative of the methane by replacing the all hydrogen, because carbon has only 4. So this is obtained by replacing the 4 hydrogen by the 4 halogen. So it is a tetrahalogen derivative. So we may consider that is a polyhalogen derivative. If you replace more than 4 or hydrogen, then you get a polyhalogen derivative. Suppose I have the ethane. So in the ethane, if I replace the 5 hydrogen. So 5 hydrogen if I replace, suppose I get this CH, now here from replace 2 hydrogen by the halogen, and from this the 3 hydrogen I replace, the total I replace the 5 hydrogen by the 5 halogen, then it is a pentachloroethane. It is a pentachloroethane. Or replace all the 6 hydrogen. So I get CCl3 and CCl3. So it is a hexahalogen or a hexachloro. I say it is hexachloroethane. So like this way, polyhalogen I consider if I replace more than 4 hydrogen by the halogen. So it is a, I say it is a pentahalogen or hexahalogen. I may say it is pentahalogen or hexahalogen. So like this way, the classification of the halogen derivatives are considered on the basis of number of halogen it possesses. If it has only one halogen, monohalogen. If it has 2 halogen, it is a dihalogen. So in dihalogen, they may be the geminal or vicinal. If it has 3 halogen, then it is a haloforms. If it has 4 halogens, they are the tetrahalogen derivative. Or if it has 5 halogen, they are pentahalogen or hexahalogen. So like this way, monohalogen and polyhalogen you can consider broadly depending upon the number of the hydrogen are replaced by number of halogens. So like this way, we can consider the classification of the organic compound on the basis of the number of halogens the organic compound possesses. Okay. Now, in the tomorrow's lecture, we are discuss the classification of the organic compounds on the basis of the hybridization of the carbon to which halogen is to be